So what does that process look like from the efficiency perspective? Because one of the things that I've heard is that with recycling, cost efficiency can be a challenge, right? And so it's sometimes cheaper and easier to make a new plastic altogether rather than recycle a used one. So how is that potential challenge incorporated into the roadmap of Flo Materials initiative?
Yeah, that's a really good question. So one of the reasons that recycled materials are seen as lesser than virgin materials is because their performance goes down typically, but their cost also goes down. So in a way, we are incentivized to recycle materials, but we're just not doing it well right now. Flow is, incentivized to capture value at the beginning and end of the materials life cycle. And the reason for that is because recycled PDKs are
Hello, everyone. Welcome to the It's a Material World podcast. I'm Puneet. I'm with David. How was your weekend, David?
It was good. I signed a new lease for my apartment, so that's always exciting, I guess. So about to have to move, but just moving into a more permanent residence. I just kind of subleased a room for now. So it's exciting.
Nice. My weekend was good too. I'm back home in North Carolina, so spent this weekend walking around Duke's campus with my brother and UNC's campus with a good friend of mine. So it was a fun time. Got a lot of outdoors time as well as spending time with the family. So can't complain. I'm here for just a while longer. I'm staying for my birthday. But it's been fun and it's been relaxing, just kind of getting situated back home, still working and everything like that. But yeah, just for today's episode, we're discussing infinitely recyclable polymers, which is a really cool concept. Our guest, Dr. Kezi Cheng, was a material science and engineering student at MIT, but then gained a lot more diverse experiences afterwards in terms of entrepreneurship, applied science, and policy. And so she is the CEO of Flo Materials Incorporated. I wanted to get your thoughts first, David, on your favorite aspects of the episode, what listeners should look forward to when they're tuning in.
Yeah, I think it's really interesting. The idea of an infinitely recyclable polymer is first very interesting. So I think she does a good job explaining it, but also she talks a lot about what the future will look like because they are an early stage startup. So really, I'm very excited about like 5 to 10 years from now when they start to reach mass production and things like that. So overall, she talks about a future where these polymers can be infinitely recycled with no hit on their performance or integrity, and they can also separate out additives, cross-linkers, etc., and then repurpose them for later use. So I think that it's much needed in the world where we use so much plastic, that if we could start to recycle a lot more without having to like downcycle, which is recycling, but using it for another purpose than the primary intention, I think that would be extremely large for our ability to become a greener society.
For sure. And one of my favorite kind of aspects or sections of the episode was towards the end when she was talking about her experiences as a female CEO and things she's learned, obstacles she's had to overcome, but also the importance of like introducing more women in this space from the leadership perspective, entrepreneurship, CEO, etc. She just shared a lot of very powerful advice, as well as just advice for anyone who's looking to make an impact in the polymer sustainability space. So those are just a few things to look forward to towards the end of the episode. But I couldn't agree more. I thought it was really interesting to hear her perspective on the challenges in the space of, recycling plastics, especially thermosets, what their roadmap looks like in the short term as well as the long term to overcome those challenges, and also all of the different stakeholders that she and the company would be engaging with, from the consumer standpoint of voting with your wallets to working with manufacturers who then work with brands, and then also, recycling facilities. So it's just really cool kind of hearing about the business model that she's putting together. And she has a really unique vision for the company. So it was definitely a very, very interesting episode. So yeah, anything else that you think our listeners should hear before we get right into the episode?
No.
Well, as always, please leave a rating and review on your favorite podcast platform and join our Discord community. The link will be in the description. It's totally free, and you can engage with other material science and engineering peers and professors and organizations. So, without further ado, let's get into it. Hello, everyone. So for today's episode, I am excited to introduce Dr. Kezi Cheng, the CEO of Flo Materials Incorporated, a startup that focuses on enabling infinitely recyclable polymers. So Kezi earned her PhD in Applied Science and Engineering from Harvard in 2021 and her bachelor's in Material Science and Engineering from MIT in 2015. She has worked on various material science technologies from electromechanical smart windows to supercapacitors to sustainable textiles. She also has experience in broader impact roles such as policy and entrepreneurship, but truly found her passion for sustainability during her PhD. So Kezi has been at Flo Materials since 2021, and we are super excited to have her join us today. So thank you, Kezi. I'm excited for this conversation.
Yeah, thank you for inviting me.
Awesome. Well, let's jump right into it. The idea of infinitely recyclable polymers sounds so futuristic and almost like a dream. What is Flo Materials' general approach to enabling this technology?
Yeah, that's a good question. So I guess some background. So currently we have about 400 million metric tons of virgin plastic produced each year, and about less than 10% of that goes to recycling. So in the US alone, about 3% of energy consumption goes into making virgin plastic. So keeping materials in circulation for a longer period of time through recycling and good recycling methods will decrease the demand for energy consumption and decrease the amount of virgin plastics produced. So we're starting there. And one of the reasons, though, that recycling is so difficult is because recycling streams are typically contaminated, they're complex, and customization recently has led plastics to be very difficult to be recycled in mixed streams. So we're commercializing a new class of recyclable polymers called PDKs. It stands for Polydiketoenamines. And this material is a vitromer resin coming from carboxylic acids and polyamines. And it truly allows for a circular thermoset resin platform. This material has two special features. First, it can be chemically depolymerized to break down the polymer into its monomer constituents, and in the process, remove additives, colors, and plasticizers. And the second feature that's really great about this material, being a vitromer, is that it's a cross-linked network that can be mechanically reprocessed, and in the process, without degrading the properties or performance of the recycled material. So I would say our platform technology will recycle material at low loss, at low energy, and high yield in a mixed waste stream to get back the same colors, designs, and most importantly, material properties. So in a way, I think PDK is a plastic from the future. Yeah, I'm happy to talk more about this.
That's awesome. And before we kind of dive into the material science of it all, I'm just curious because you've been involved with so many different fields within material science. You said you found your passion for sustainability during your PhD. So I guess I'm just curious, how did that passion kind of uncover itself, you know?
Yeah, I would say that it has, looking back, it has always been something I was very interested in. Sustainability has always been something I was extremely passionate about, but I never saw that as I was moving forward in my career. One thing that I did post MIT was work at a small company working on non-fluorinated coatings for textile. And it's really, finding a way to make sure that we can move away from fluorines and have other functional materials to give the same performance like wetting properties as fluorinated polymers. And I've also worked on battery research and likes of that. I think one thing that I noticed in My PhD program was when we were designing these actuators, these multi-layered actuators, and they would be 20 layers, and they would be layers of silicone and carbon nanotubes. And it was very hard to actually make these stacks. And if one layer like had a hole in it, the whole stack goes to waste. And for me, it was just a super wasteful process. And this question came to my mind, can we make these polymers healable, recyclable, such that we can actually also take back the valuable components in this mixture, which are the carbon nanotubes. So it was around that time that I started working on dynamic covalent chemistry. So it's a new class of materials as well that allows bond exchange, which Vitromer falls under. So these covalent adaptive networks that allow self-healing, allows recycling, and allows low energy bond exchange to occur.
Well, yeah, maybe going into this polymer of the future, you said that it can be easily recycled mechanically and be separated from the additives and other things that we need to add to make sure that we can tune it for each different application. My question is that usually a general rule of thumb is that something that's easily like divided or like easily recycled means that it won't have very good like performance. Basically, if it's easier to separate, then when you're using it, it could be not as strong or not as compliant, etc. How does this polymer of the future handle like more intense use applications while still being easily recyclable?
Yeah, so going back to Vitromer materials, Vitromers are covalently cross-linked networks, so they have higher performance typically than thermoplastics. So we're talking about thermosets like epoxy and polyurethane materials. They do have a higher mechanical performance, higher thermal performance, and chemical resistance. But what's special about them is that when heated at higher temperature or under different stimulus, their topology can be thermally activated through bond exchange. So the total number of bonds in the network stays constant, but there's a rapid exchange of bonds breaking and bonds reforming. So in that process, you can reprocess the material with lossless performance at the end of life. So this is kind of different from material like PET, for example. PET and a lot of the 1 to 7 plastics are thermoplastics, and they undergo mechanical recycling, which is you grind them up and then you thermally reform them. The problem with that is if you're not taking out the plasticizers, if you're not taking out the colorants, eventually your plastic clear bottle will become a non-clear bottle. And eventually the mechanical properties will also go down with the number of recycling times. And this is something that we are trying to avoid with our plastic. So we can both mechanically reprocess it, but we can also break it down fully back to monomers and the process, take out all these plasticizers, all these additives, and then re-add them at the next life cycle.
So what does that process look like from the efficiency perspective? Because one of the things that I've heard is that with recycling, cost efficiency can be a challenge, right? And so it's sometimes cheaper and easier to make a new plastic altogether rather than recycle a used one. So how is that potential challenge incorporated into the roadmap of Flo Materials initiative?
Yeah, that's a really good question. So one of the reasons that recycled materials are seen as lesser than virgin materials is because their performance goes down typically, but their cost also goes down. So in a way, we are incentivized to recycle materials, but we're just not doing it well right now. Flo is, incentivized to capture value at the beginning and end of the materials life cycle. And the reason for that is because recycled PDKs are 20 times lower in cost and about 40 times lower in carbon emissions than the virgin materials. So if we're able to do that and have indistinguishable properties between virgin and recycled materials, then we are incentivized to be both the supplier and the recycler and trying to provide a circular turnkey solution for our customers in the process.
So what does that look like exactly when we scale it up? So I know that eventually the idea is that we would scale it up to be mass production and have it everywhere. Can it be a plug and play in current solutions, or is it going to be another line that you would have to add? I guess the question is it a similar process to what we have now, or is this a completely new mechanical separation process?
Yeah, so there are two scale-up issues. The one scale-up issue is production. Because it's a new material, we need to increase production to lower cost to be competitive with the existing plastic materials or things that we're trying to replace. And that's a tough piece of the puzzle for any new materials company. The other problem is, how do we scale up the recycling? And I would actually say that the recycling process, we'll tackle that first. The recycling process is relatively easy because we can recycle these materials at room temperature in acid solution. So I can envision a way where we can do the depolymerization in a much more modular, localized manner than these larger facilities that take many, many different types of materials and have to separate them or, break them down to much smaller molecules than our monomers. So I do see the recycling aspect being able to scale up relatively easy. The production aspect is harder, but if we're taking more materials back, that goes back into our virgin material pool of supply. So I would say that we would want to scale up to a certain point and then, also rely on the recycled material as our supply. But any scale up is hard. And one of the reasons that we're tackling a smaller beachhead market is for that reason. We want to make sure that the cost goes down in the near term while we're scaling up to get a product into market. And our beachhead product is actually an eyewear frame. So I don't know if you know this, but eyewear frames are cut from sheets of materials that are around 100 grams in mass, and your frames themselves is about 15 to 20 grams. So in the process of subtractively manufacturing that using CNC machining, you are losing about 80 to 85% of the material already just in the production process. And we're hoping to collect that from manufacturers who make frames. And I think that this product is minimally capital intensive, minimally material intensive, and it allows us to de-risk the science, the manufacturability, and the economics of a closed loop material to understand how we can do this for other materials. For example, bigger markets like nylon or polyurethane that are in the automotive or fashion industry. Right now, there's annual production about 500 million pounds of acetate waste. But if we're looking at nylon, that goes to like 8 billion pounds. And if we're looking at polyurethane, that goes to 50 billion pounds. So there's a way that we envisioning scaling up our material to either serve the needs of existing plastics in other markets or other applications, or make those materials more circular with components of our system.
So remind me, are you only working with polymers that kind of fit under the thermoset category, or are there other kind of materials in scope of your technology?
Yeah, no, so not only thermoset. So, we are looking to make thermosets more circular, but we can also potentially make thermoplastics higher performance, more chemically resistant, the properties of thermoset that we have through our cross-link networks. So anything is a possibility, I guess.
Yeah, for sure. I was just curious because I would love to hear more about your vision for Flo in terms of kind of the materials that you work with, and also like I guess another thing that I was thinking about is you're separating like the additives, colorants, etc., from these polymers. Is there any way where you can reuse those additives as well, and potentially make use of everything that you're recycling?
Yeah, that's the plan. So, when I talk about eyewear, I'm talking about getting homogeneous waste, large stream of homogeneous waste from the manufacturers, but there's still 15% of that that's going into post-consumer waste. So in the short term, we're hoping to, work with manufacturers and get waste back and just recycle our monomers out of the system, so the triketone and the polyamine. In the long term, not only do we want to get the additives and potentially the plasticizers back to reincorporate into the mixture, but we also want to work with consumers. So we also want to close the full loop. But as a startup, we have to pick our focus right now. And our focus is large volume, homogeneous waste, and making bigger impact in the short term.
I'm curious. So the primary use of your polymers are in thermosets, but a lot of things that we use today that could benefit from recycling are thermoplastics, such as single-use plastics. With that, the manufacturing methods are very different. How can your polymer handle both types of manufacturing sets?
Yeah, that's a good question as well. So we are looking at how to manufacture our materials into different forms. So and through different methods. And right now we're already doing compression molding of our sheets, which thermoplastics can do as well. We are also looking at extrusion and injection molding and potentially 3D printing of these materials. And then later down the line, maybe looking at how to make it into a foam or a fiber. This is really a material platform. So, you can envision exploring different manufacturing methods that are already being used for thermoplastics and thermosets with our material.
Maybe a little bit so far down the line, but for foams, correct me if I'm wrong, but basically the basic process is you take your polymer and you blow bubbles in it. And so your EPS, or expanded polystyrene, is like the foam that we currently use in like foam cups, is like notoriously hard to recycle. When we talk about all of these things, of these different kind of substrates and different ways of producing, does it all kind of fall into, at the end of the day, the goal is to be able to put into an acid bath and let it dissolve into monomers? Or do you think you'll have to change the recycling method as you scale to different manufacturing techniques?
Yeah, we are already actually looking at different formulations of PDKs that could be recycled in a mixed stream with other types of plastics or glass or carbon fiber composites, etc. And we're looking at how to basically draw out different triketones or different polyamines at different temperatures or different acid solutions. So there will definitely be customized solutions for different types of products in the long term. In the short term, simplicity is key, and we want to have one polymer and get our monomers back, and make that polymer at the same performance. So there are short-term, I guess, milestones, and then also long-term milestones, which is figuring out the right recycling method for that particular formulation that we're going to use for that product.
Then you talked about like the short-term and long-term milestones, and I'm sure as CEO, you kind of have to discuss this quite frequently with stakeholders. But for the purposes of our podcast, can you discuss, you mentioned eyewear as a focus right now, or just an application regarding your technology. What does it look like, in the short term, as well as like maybe 10, 15 years down the line, in terms of the people in the industries that you would want to work with?
I want to be like the Gore-Tex of like recycling in some ways. It's something that people knows this material works for a special purpose. And down the line, we want to work with manufacturers. We want to work with brands. We want to work with different material recycling facilities that's located, in the US and abroad as well, and really figure out the logistics part of a circular business proposition and the forward and the reverse logistics and geographic locations and transportation, all the things that, have to come together when you think about circular businesses. And also consumers. We want to work with consumers who are seeking real solutions with waste mitigation and also real green solutions. We're not trying to greenwash and put out another plastic that might contribute more to the problem. We're really trying to fix the existing problem that's out there. And my bigger vision is really to kind of demonstrate to the industry and to large chemical companies that there are solutions, there are technical solutions, there are feasible, profitable solutions. And, they need to get on board with these and they need to adopt these solutions, because if they don't, then they'll be left behind.
When you talk about greenwashing, I think that's a great point. So a lot of things that companies have done today is do things like paper straws, which sacrifice performance for sustainability. And even then you have to coat the paper in like a plastic, which is not super recyclable either. So when we talk about your product, you're not really trading it off. I guess one question for you is, what's the cost point compared to these other green alternatives? Is this going to be a similar sustainability play, or do you think you can eventually, at scale, of course, be competitive with the other more mainline plastics?
Yeah, I think for right now, for our current beachhead, which is replacing cellulose acetate, they sell these sheets of acetate for $20 to $50 per kilo, which is a super high price point for any types of plastic out there. And that's the reason that we're going after this, is because of the high price point. And we can achieve price parity with this material without asking for premium, but we could also potentially ask for premium for early stage. The material, we believe, once scaled up, can compete with materials like nylon and like polyurethane. And more development needs to be done to see how we can decrease the cost to compete with other types of plastics. Probably not single-use plastics in the short term, because those are just really cheap. But the goal is to work towards that. And one thing that's really interesting is that potentially triketones can be made from bio-based materials. And we would also try to figure out if that can decrease the cost of the total PDK polymer in the long term as well.
So I'm curious because you've mentioned with the long-term vision, you want to you want to engage with consumers, recycling facilities, manufacturers, etc. So I just know that, those are a lot of different potential, I guess, messages, right? Like your messaging strategy may be different when working with each of those parties or those organizations. So as CEO, what does like that strategy look like in terms of, what do you focus on now? How do you kind of shift your priorities depending on maybe urgency or even just kind of the long-term vision?
Yeah.
Or is it even like a comprehensive kind of like brand play, right? Where you're addressing a bunch of different parties or stakeholders at once? I'm just curious.
Yeah, so I would give an example of eyewear because that's the market that we understand the most at the moment. For eyewear, there are brands that work with multiple manufacturers and then also manufacturers that work with multiple brands. And in this particular setup, we can go to a brand and tell them we have a new material because they're the ones that are actually buying the materials from us, even though the waste that we're collecting are from the manufacturers and the people that we're working with are their manufacturers. So for eyewear, we would probably go to a brand and get their interest in a new material and our value proposition to increase the materials efficiency for their manufacturers and start to test our materials within the existing equipment that these manufacturers use in their facility. And so that's one way of doing it. The other way of doing it is testing our material with the manufacturers and asking the manufacturers to go talk to their brands and say, we have a new material that works really well, that performs just as well as acetate does. And, this could differentiate you in the market. So, why not adopt this? Why not try this? Do a pilot. So that's how we're seeing, the brand and the manufacturer play in the eyewear space. But I think consumers are asking and demanding for solutions now, and brands know that. So there is also a potential, way there to kind of get our material into the hands of certain brands.
Yeah, sticking with the vision, what do you think the global landscape of infinitely recyclable polymers look like to you? Are there countries or regions you think are going to be early adapters? I'm sure there will be, but maybe in 10 years, what does this look like to you on a global scale?
Yeah, I think policies are really important in this space, and policies are more mature and comprehensive in certain places than others. Currently in the EU, there's a lot of different laws out to incentivize recycled materials. And what's great is that the eyewear space, the premium eyewear manufacturers are actually located in places like Italy and France, and we're learning a lot about these laws. And yeah, so for example, in the EU, there's the waste shipment regulation that prohibits shipment of waste from one member of the EU country to another for disposal and landfill, which it forces the individual countries to figure out how to deal with their waste. It's also great because some of the manufacturers that we work with in Italy and the other manufacturers that we work with in France, we can think about them as clusters and start to think about how we can co-locate our recycling facility in clusters within the country. So, it helps with even thinking about the logistics of recycling. The EU also has a circular economy action plan, which requires producers to disclose how many unsold goods they dispose of, why and how at every stage of the value chain, which is really interesting because a lot of material is actually lost, ends up in the landfill in different production stages. And due to different yields of making that product. And typically consumers don't know these numbers. And just having more information on this, I think will cause consumers to make certain decisions with spending, which is really important. In the US, we also have a lot of new policies out. So the US Break Free from Plastic Pollution Act promotes solutions for marine plastic pollution, which you've probably heard of, nets in the ocean, plastic water bottles. There's just a lot of ocean pollution problems with plastic, and we are starting to address that. The US Reduce Act establishes a tax on virgin plastic resin, and I think they're starting at 10 cents per pound in 2022 and hoping to go up to 20 cents per pound in 2024. There's also the US Recover Act, which is in response to China not accepting our waste any longer. And this is a way to strengthen the US domestic recycling system. I think the US policy is still young, and I think we are starting to incentivize manufacturers and big brands to think about new options and figure out alternatives for materials and processes. And I think this pressure will grow with the climate crisis and become more front of mind for legislators and consumers coming up.
So, as an early stage startup, what do you think is your biggest or like your primary challenge that you're working on overcoming at the moment? Is it material science, like technology related? Is it policy related? Maybe both. I'm just wondering.
Yeah, I mean, I can tell you my 6-month plan, and there are always a lot of challenges with early startups. Right now I'm hiring, so I'm bringing new scientists onto the team that I'm really excited about. But finding the right people to join an early stage startup is difficult, and you have, growing the team from the foundational stages is tough. And you want to find the best people, you want to find passionate people, you want to find hardworking people, and people who align with your values and the values of the company. So that's my primary goal at the moment. And we're also fundraising for our seed round this summer. So the market is questionable, but you still have to go out and do it because you need funding to support new technology and new developments. And then also getting a new lab space. Right now we're at Lawrence Berkeley National Lab, and we're supported by this program called Activate, which funds technical entrepreneurs and also gives them free lab space for 2 years through the Department of Energy support as well. And we've been super lucky to incubate our company within the lab for free. And I don't know if we can do this without the support of something like this type of program. But eventually we have to leave the nest and get our own lab space. So there's a lot of, hurdles and challenges and product development, getting a product into market. We're hoping to do that by Q1 of next year. Have someone purchase our material and at a few hundred kilos and test out the circular business model. And so I would say, the technology is like the hidden piece behind it all, where you have to get it to work to get the product. You have to make sure that you hire good people to continue developing this platform and understand the challenges with this new material, understand the challenges with recycling this new material and interfacing it with existing plastics. So plenty of lot of challenges,
Awesome.
but fun.
Well, as you go through this, we would find it very interesting if you could describe your experiences in innovation as a female CEO. How does the number of women in the space or lack thereof shape the innovation space in core technical startups like yourself?
Yeah, I reflected on this quite a bit over the past couple of years. And I went to undergrad at MIT where we had about 50% of male and female split. And I think it was kind of a utopia I lived in. This is what I believed the world will look like. And as I went to do my graduate school, I saw less and less women and in the program that I am in and in entrepreneurship and in hard tech, I saw less and less women. So yeah, the further went from MIT, the more I saw the reality currently. And this year I went to a conference in Abu Dhabi for International Women's Day. And this is a data that, Hillary Clinton said. She said only 2% of women-led teams in the US raise venture capital funding. So that's an insane amount, like small amount, given that over 80% of purchases and purchase influences are made by women. So women have a harder time fundraising. There are less women, there are less companies, there are companies led by women. And I think we still have so much to do in this space. Like there's still so much gap to close. That just think about that number, I guess.
Yeah. So from your experiences, then, do you have any advice, as a material science podcast for especially like the women who are potentially seeking to follow a path similar to yours, or, even ones who are looking to pursue careers in academia or industry? Do you have any advice for them to, continue to push forward and try to bridge that gap, I guess?
There's a class that I TA'd for in grad school. It's called Science and Cooking. And it was an amazing like entry level class that I just encourage everyone to take if they have that offering. And it was a class where first you have a Michelin star chef come in and show you this crazy food invention that they've developed. And then you have a science class that talks about viscosity and elasticity and how to make pancakes more elastic and how to measure the elastic modulus of pancake when you add more gluten or etc. And then, you do a lab-based class on that. And I found that class to be just such a great way to actually get more women excited about science. I think it's because, women are typically told that I don't know, I think, discouraged from going into hard tech, or science fields. And I think any way we can just lower that barrier to entry would be great, because everyone can do science. There's not men don't do it better than women. And I would just encourage ways to allow women at a younger age to get introduced to science topics, to feel comfortable and to know that to get interested and know that they can do it. And I think from my own experience, there's a Taylor Swift song, so for the Swifties out there, called Invisible String. And I think about that with my career path quite often. I would have never guessed I'd be doing what I'm doing now. And I love what I'm doing now. But I do remember, like, there were points in my life where I was really inspired and was really curious about sustainability and, finding greener solutions for the world. And I remember, I think in 9th or 10th grade, I read an article from National Geographic about using algae to sequester carbon for growth as a way to mitigate greenhouse gases. This was, 15 years ago. And I was amazed at new technologies to solve big problems that we have in the world. And I followed my curiosity into science. And then I found material sciences at MIT as a field where I can invent and, learn new things that connected chemistry to physics to biology, and continue on to my PhD, where I found a place where I could keep asking questions and keep being curious, and then eventually into entrepreneurship, where I can now build and find a team of other people who want to build with me, and grow a team of recycling warriors out there. And yeah, I would just say, like, follow your curiosity and put in the work and find help, and it will lead you to the right places.
Would you say that that's the same advice you would give to like students looking to make an impact in the future of polymer sustainability, or is there any advice from that standpoint, from like the material science standpoint, for those looking to make an impact from the polymers and sustainability? Because I guess the advice that you gave can apply to everyone, but it also is like entrepreneurial focus. So I would just love to see if you have any other kind of concluding thoughts.
Yeah, I would also say, do some internships, because then it helps you figure out what you don't like. And if you figure out what you don't like, you're closer to getting to where you want to go. And I did a bunch of internships, and I worked at Chevron for a summer, and I actually really enjoyed that experience. And, like, a very large organization that cared a lot about safety, for example, but the goal for that company did not align with my own values. And it was a great way for me to actually say no to something and say yes to something else. So I would say find, experience things, and then it will help you figure out what you want to do.
Yeah, for sure. And you mentioned it before when you were talking about just reflecting on the past few years. I think that's another key component to gaining new experiences is reflecting on what you enjoyed about it and what you perhaps didn't fully align with, like you were talking about, because every experience you can learn from, and then you just continue to make decisions based on those patterns, right? So, um, yeah. Well, thank you so much, Kezi, for joining us today. This was a really wonderful discussion, and I'm excited to see Flo Materials grow and continue to make an amazing impact on our world today.
Thank you so much. Yeah, it was great talking to you guys, and I hope we get more recycling warriors out there.
Absolutely.
As a materials engineer, we can make an impact in nearly every single industry. But with that versatility comes a lot of different options to choose from. So if you have no idea which industry or position is right for you, believe me, you're not alone. I've been there, done that. But just for a moment, imagine narrowing down your ideal role and company by the end of this week. Imagine being able to secure your dream job offer without having to apply to hundreds of job openings. Our online course, MSE Academy, includes video testimonials, resumes, interview prep, and mentorship from materials engineers who have been in your shoes. We also connect our members with companies and industry professionals in our expansive network to help accelerate your job search as much as possible. To learn more and get started, simply click the link in the description below. And if you enroll within the next 24 hours, we'll add 3 bonus career development resources. I hope to see you there.